So the start of physics really starts with one-dimensional motion. And we try to analyze motion and try to understand how we can use this analysis to be able to predict where objects are going to be, to know where things should have been, or to just to be able to understand how things are moving, okay? The basic with this is first understanding position and origin, right? Where a position is really the location of any object measured from an origin, right? And an origin really can be anywhere we want to be. So I'm here at Emerald Campus, and so that could be my origin. And my position, maybe, if this is Emerald Campus, now we're only going to go one-dimensional, so we're just going just like on a number line. My origin is going to be my 0 position, okay? Maybe I live over here, here's my house, right? And when I'm there, I'm at a position of 20 miles. I live 20 miles straight away. Again, we're going one-dimensional motion. We're not turning left or right, just forward or backward, right? Maybe the grocery store is over here, and that's at -5 miles. And so those are positions relative to my origin. And again, my origin could be anywhere. I could choose my origin. If I wanted, my origin could be here, right? And then my positions would be based off of this origin, or my position here would be -20. My position here would be -25, okay? The length between them doesn't change. It's just their position changes based on the position that I chose as my origin. Same idea, if this is my origin, that's 0. Emerald Campus would be at +5. My home would be at +25. Again, the lengths in between them aren't changing. It's just what is changing is where is my 0 point? And the nice thing about my origin is it can be anywhere, right? And in physics problems, we choose where that origin is, and you'll see some benefits of choosing it at certain locations. It can make the problem much easier. Certain locations can make it harder. So we'll try to talk through that as we go throughout the year, okay? The other idea is something called displacement, right? And displacement is going to be pretty much just the length from start to finish. So what's my day, right? My day starts here at my house. I maybe have to go pick up a supply from the grocery before school. So I drive to the grocery store, and then I spend my day at Emerald Campus teaching, right? So what would my displacement from there be? Well, it's the length from where I start to where I finish, okay? So what we don't really care about is the entire motion, but what we care about really is from starting position to ending position. So this is going to be my initial position, which we'll indicate with this. So position is indicated with an X, as long as it's the horizontal. If we're talking about vertical motion, it would be Y, which would look like this, Y initial. The 0 stands for kind of 0 time, right? If time is 0, that's where I would be. And then my final position, I indicate with XF. Sometimes you'll see it indicating when it's just X, but that's my final position, okay? So what is the length then? My displacement is just worried about this here, right? What's the length from where I started to where I ended, okay? Now this is different than distance, right? The distance of travel is the entire path, okay? So if we look at this scenario, what is the total distance that I traveled, which is lowercase d? Well, I went 20 to -5, so I went 25 miles there. And then I came back to Emerald Campus, which was another 5. So my entire distance is 30 miles, okay? Whereas displacement is different. It just cares about this here, right? And we're actually going to have our first equation, which stands for displacement. So displacement is indicated with a delta, right? So that's a delta. That's the mathematical symbol. And basically what this means is this is change. So the delta stands for change, and then X stands for position, okay? So delta X, displacement, literally means What is a change in position? How much does your position change? And we're going to measure that or calculate it by doing position final minus position initial. Okay? And so we'll do all three examples here, depending upon what was my origin, right? So I'm going to do it based on the color. So let's use our black position. It's kind of what we did. So our final position was 0. So our displacement equals 0 minus my initial position, which is 20. And so what is my displacement? That's negative 20 miles. Okay? And the negative is very important in that the negative tells me I went in that direction. Okay? So the negative tells me direction, and we'll explain that here and elaborate on that here in just a second. Okay? Let's do this where my origin was at my house. Right? My change in position is, again, final minus initial. So what is that? Negative 20 minus initial, which was 0. And so we get a displacement of negative 20 miles. Hey, that's kind of cool. It doesn't matter where my origin was, we always got the same displacement. So again, the origin can be anywhere. You just got to make sure you're using it consistently. Okay? I'm sure you can understand, but we'll go through it. If I chose my blue origin, what was that? As the grocery, right? My initial position, or my final position, excuse me, was 5. My initial position was 25. So 20, or 5 minus 25, is, again, negative 20. So we see, in all three of these circumstances, I get a displacement of negative 20 miles. So I said earlier that displacement is a vector. Well, what does that mean? Okay, so in physics, we're going to deal with things that are both vectors and scalars, right? Vectors are a little bit harder for us to understand sometimes because there's two things that vectors deal with. Vectors deal with something that's called a magnitude and a direction. Okay, so that's what vectors have. They have two parts, whereas a scalar typically will only have a magnitude. Okay? Scalar is just magnitude. And what that means is things that are a scalar are like time. Okay? Your weight, mass. Those are things where there's no direction to mass. There's just a value, right? There's no necessarily direction to time. You can go forwards and backwards in time, but really time is just a single value, okay? There's not like 10 seconds, which is going that way, versus 10 seconds, which is going that way. Someone can move in that direction, but time itself is a simple value, okay? Whereas a vector, for displacement, the vector of displacement tells us two things. The first thing it tells us is how far, right? Our previous example was 20 miles. I ended up 20 miles away from where I started, okay? That's the magnitude. That's what's considered the magnitude. The numerical value is the magnitude of any vector. A positive or a negative is going to tell me the direction, right? My example was I started here, I ended here, so a vector is an arrow. I can draw an arrow to show my vector. This is my displacement, okay? The value of that, or the magnitude, right, is how big the arrow is. That's my magnitude. Okay? My magnitude is how big the arrow is. The direction is which way is the arrow pointing. Right? Another example is, maybe when I go home, I start here at Emerald Campus, right? Maybe I go home, and I go home, right? The vector that would indicate that displacement would be here. Okay, that would be my displacement home. Whereas this was my displacement when I went to work. Okay? Notice the magnitudes of those vectors are the same. The displacement in terms of its value is the same, it's 20 miles. But they're different values for the fact that this is a positive 20 miles and this is a negative 20 miles. Okay, so the direction does make them different. All right? We'll deal with a number of different vectors as we get into two-dimensional motion. It'll be a little bit more important to differentiate between a vector and a non-vector. But so we can start to gain an understanding of what it means for something to be a vector.